Hey everyone, so today we will be dealing with the question of when to use machine learning and when to use deep learning. Okay, so honestly, I was thinking about this question and I was wondering why nobody has till now asked me this question, because everybody just wants to learn the model, which is really good, but you should also know when to use which model, right? Now obviously in machine learning there are many models, and when to use which is a question that I have to cover someday. But there are definitely broad categories where you can say on this particular scenario, in this particular, let's say, case, ML is going to be the best option, and on certain cases deep learning is going to be a better option. Now the question is, what are those cases? So for today I have basically found out 6 ways by which, now one or two you might be able to even guess, but I'm going to just put it out there so that we all know what those 6 are. Now you can come up with the seventh, eighth, but these are the 6 ones that I have. 6 reasons, are the 6 distinctions basically, are on the grounds on which we will do our we'll take our judgment. Okay, so obviously there are some models that are in ML, and in DL, even though it's just neural network, there are types of neural network, right? So if you use a CNN, most people know it is used for images. If you're using, let's say, a transformer or a LSTM, well, most people can say this is for text based. So if you're using a simple neural network, you can use it, definitely not for images, definitely not for text, it's mostly for normal data. Okay, now obviously I have seen people using CNN for text. I have seen LSTM, there was a pixel RNN. So yeah, you can also use it for pixel RNN. You can also use an RNN for images, and neural network obviously can be used for many things. I get it, but these are mostly used for images. These are let's say already defined, understood, and it's common knowledge. Okay, so these are the things. So now what are those 6 attributes on which we will be differentiating or trying to take a decision of whether using machine learning models or deep learning models? So first criteria for making that decision is features, right? So if you have a data set, something, let's say iris data set, okay, where you have petal length, petal width, and then sepal length and sepal width, these are features, right? These are features. So obviously you will be giving it to a machine learning model, because in order to train any machine learning model you need features. You cannot give them raw data. So instead of now features, if you have images, let's say this is an iris image. Okay, I'm just drawing it like this. This is this is the virginica flower. Now this is your setosa, and I don't know how they look like, but I'm just telling you. Okay, this is setosa, this is virginica. Then you will have versicolor. Let's say versicolor is totally different, is something like this. Okay, so whatever, you get the idea, right? If you have plain images, obviously you'll not be, now, oh, you can say, okay, why I can definitely go on and find, let's say, your hog features and then your sift features. Okay, all that is fine. Again, sift you'll not be able to use because a number of key points and number of features are not defined over here. It's not constant. But what I'm trying to say is that it definitely looks like a problem for a CNN, which is deep neural network. Why? Because we do not have well defined features over here. We just have raw images, raw data. So if features are available, we will use machine learning. If features are not available, we will be using deep learning. Okay, so now second criteria. Okay, the second criteria on which we will be taking our decision whether we'll be using machine learning or deep learning is size of data set. Now I think some of you might have already thought about this, but smaller size data sets, let's say, you will use ML. If you have large data sets, in MBs and MBs and GBs and PBs and TBs, all that stuff. Okay, maybe not PB, but let's say till TB. Okay, you will be using deep learning. Okay, from a few MB, or sometimes even KB, it also works, but mostly from MB upwards you use deep learning. If your data set is in KBs, you use machine learning. Okay, now this is not a golden rule, but mostly it works. So yeah, you can do that. So for example, again, you have iris data set, you have 150 rows over there, definitely machine learning. That does not mean you cannot use neural network, a simple neural network, and it won't give result. It will give result, but mostly 150 rows to, let's say, if you have anything less than 10,000 rows. First of all, if you have rows, it means you have features. If you have features, automatically you know what you need to do. But let's say if you another way of looking at it is, if you have less than 10,000 rows, you would probably be looking at machine learning. If you have greater than that, try simple neural network and deep learning. Okay, for example, you are doing something like a word net. Okay, try deep learning, simple neural network. Okay, so I hope the second criteria is clear. Now let's go to the third criteria on which we will be deciding whether we use a machine learning or deep learning, is the complexity of task. Now I think this also is evident, otherwise I'll explain. Okay, complexity of tasks. If you have a simple task, right? If you have a simple task, if obviously simple tasks mean your work will also be done by a smaller data set, and if you are using a smaller data set, you will be using ML, right? So if you have a simple task, you use ML, something like iris data set, or you can even go to the extent of saying MNIST. Okay, and so all these basic stuff. Okay, if you have all these things, you can use to say which does not involve any human like capability. You can use statistical models, so these can be done by statistical models. What is statistical models? ML, right? You will use ML. However, if you have a complicated data set, for example, you want to generate images, Gen AI, yeah, best of luck doing Gen AI with ML. So you will need deep learning. Okay, so if you are doing something that's complicated, that's human like complicated, or human like, you would definitely want to do deep learning. Okay, so if you have a simple task, you have just a normal prediction on a small data set, ML. If you are doing anything that is complicated and all those things, you do deep learning. Okay, now the fourth way we decide whether we will be using machine learning or deep learning, the criteria is interpretability. In machine learning, obviously, since features are there, and let's say you trained a logistic regression, so let's say you trained a logistic regression, and finally you got an output over here. Okay, so let's say whatever you are doing, you get an output. Obviously, if this the weight of this particular neuron is high, it means weight of this particular neuron is high, it means this particular neuron has higher weightage, right? So which basically mean that whatever feature we were entering there is more important. Now it can be positive, negative, I'm just saying magnitude. Okay, if this one is almost coming to zero, okay, then it means that this particular neuron is not that important. It does not have a lot of discriminatory power or distinctive power. So which means you can interpret, okay, the what to say, your features, and then can make logical conclusions. Okay, so for example, this was anything, anything, any feature it can be. You can definitely put more importance if the magnitude of weight is high. Okay, if the magnitude of weight is normal, almost close to zero, it means you don't need that. Okay, and obviously with deep learning neural networks, we say these are black boxes, because we don't know what they learn, but they work, and they definitely work. They have shown themselves, they have proven themselves, which means so these are the interpretability is very, very low here. And that's why when you don't want you want to, I mean, where you are able to or ready to compromise on the interpretability aspect, you definitely go for deep learning. Where let's say you are in a bank, and credit policy, all that needs to be decided based on concrete features and columns. That is when you will use machine learning, because you cannot lose the interpretability aspect. Okay, yeah, for example, in Gen AI, we don't care what values are learned. We just say this is the prompt, and we get a good image, we are happy. We don't care what the model does in the between. Okay, because nobody wants to know. Okay, so that's number 4. Number 5, am I numbering it correctly or not? Number 4, number 5, yeah. So on the 5th, it's not in any order. Okay, it's not that the first one is more important, the second one is less important. No, I'm not saying that, it is random, but all of them are important, I would just say, but to a certain degree. Resources, this also, I think you might have already guessed it. You can train a simple machine learning model on your even CPU. If you are going to train a deep learning model that is going to do real stuff, for example, Gen AI, you don't need GPU, you need many GPUs. Okay, which means this is not only costly in terms of electricity, it's also costly in terms of money, it is also costly in terms of time. The clock is, it's also costly in terms of time, and mental harassment, if you consider that, because one thing that happens is you see the loss going down and then you see a spike, and this is what is going to give you a lot of headache. Okay. And there are times when you realize after 3 hours that you have committed a mistake, and 3 hours also means I don't know how many dollars depending on the company you're working for, which basically means now, if you get this spike, it does not always mean that there is something wrong. It can happen, but mostly if you get a big spike over here, it means that like something like a big spike, something has gone wrong. Okay. So resources is something definitely you should consider, the number of dollars and the time that you are spending. Finally, I got a correct clock. Okay. The sixth, let's say, the deciding factor is, it depends, mostly I say, but it's not the most important thing. But it might come in the resources only, but I have just made a separate column or separate point: space. Why? Because this is during inference time, this is during training time. That's why I have made a different column. Space. Why? If you have a big model, inference is going to be slow. If you have a small model, inference is going to be fast. That's why you see things like quantization of deep learning models. Why? If you convert from float, let's say 64 to int 8, it will be a bad idea to from going from float 64 to int 8. But let's say you did it, or even if not in every case bad idea, but generally speaking, well, you can get definitely some good speed upgrade. Okay. So space, again, if you have a model that is in, let's say, kbs or at max mbs, you can definitely use it in your what to say, your project. You can use it on cpu. However, if you have a model that's in gbs, well, you cannot put it on, I don't think you'll be able to do on custom, let's say, home pc, okay, or a desktop. You'll not be able to do. You will need servers, basically. You'll need data centers. These guys can do it. We can't. On our laptop and pcs, we'll not be able to do it. Okay. So I hope the concept was clear and those 6 points were very, very clear to you. If you like the video, please like and subscribe. Thank you very much, and bye.